Okay, perfect. Good afternoon, everyone. Welcome to CHADS Network Security and Privacy Cohort Week 3, Common Network Intrusion Tactics. Now, our method of delivery changed from online meetings to pre-recorded videos because you guys have very diverse times and nobody was agreeing as to when to meet. So this would be the most inclusive way to deliver this information to you guys. Okay, so what we'll learn today is network security, network intrusion tactics, and network attack protection. Here, let me see if yes, this does still work. Perfect. Okay, so we'll go over some common network intrusion tactics. I believe that we only have the time to go into in depth into DDoS attacks, but I'll try to cover it all. So we'll have malware, spoofing, packet sniffing, and packet flooding. All right, why defend against attacks? So attacks leak valuable confidential information, damage reputation, reduce customer retention, and cost money and time. Now, we've all heard this before. Obviously, it's commonplace to understand that these are the risks that come by. So I wanted to show you a few examples, some far away, some closer to home, about why this is so important. Because I believe that as cybersecurity professionals, we kind of lose sight of that. So we have Israel Link Group hacks ran a cryptocurrency exchange in $19 million heist. This was a recent event. Yeah, in 2025. I was trying to find the most recent events. And then I'm sure that a story that you guys might have heard before is 16 billion Apple, Facebook, Google, and other passwords leaked. This is not really a story. This is not really a story that is truthful. In reality, all these passwords were already publicly available on the internet. And just a research group decided to investigate and see how many passwords have been leaked since the dawn of time. And it ended up being that many passwords. It's not an event. So this is a misleading title. So we had another hack attempt for Co-op, and they had to shut down their IT system after a hack. I believe this one was done via remote execution of code. One that's closer to home is the Power School hack. I'm sure that we've all heard about this. This one was via social engineering, I believe. So I added a little bit more details. So U.S. college student pleads guilty in data breach affect North American school systems. So it says that he used the credentials of a Power School contractor in September to gain access to its network and obtain student and teacher data. I didn't see many articles cover how that data was leaked in the first place. However, one article was talking about this information was left just out in public, and he took note of it. And then, yeah, he pleaded guilty to cyber extortion and aggravated identity theft, and it's at least 2 years in prison. So these things have consequences, as we'll see. Another one that's closer to home that you might have not heard about is that AHS, they are constantly under a pressure from attackers, especially due to the political landscape as of late. So there's a lot of large number of attacks that occur. Now, this one wants to prevent social engineering, but AHS itself gets hacked all the time, and they need to have bolstered defenses to defend against this. So it was only 180 gigabytes. I believe that was because of subnetting, because of splitting up their network and their storage solutions into multiple compartments. Only one of them was broken into, but 180 gigabytes of very sensitive data is still very expensive to buy. That was in 2021. And then the one closest to home was at the U of A. And it was a student basically made malware and put it up onto a lot of the university computers, as we can see, more than 300. And then that was basically a keylogger, which would log passwords and usernames. So distributing malware. But again, this one was charged with cyber crimes. I don't believe that he went to jail. I believe that he got a suspended sentence, but still, that is on your record now. Yeah, the particular malware was designed to harvest the university's primary ID password, so just a keylogger. And malware is one of the things that we're supposed to talk about in this presentation. Okay, common types of attacks. So we have network interception attacks, kind of like packet sniffing, which is a little bit of what my research is in. Then we have backdoor attacks and we have denial of service attacks. So network interception attacks work by intercepting network traffic and stealing valuable information or interfering with the transmission of that information in some way. So malicious actors can use the hardware and software tools to capture and inspect data in transit. As we've talked about in the previous video, we could use Wireshark for this purpose. We'll talk about this more in depth later on as well. And this is referred to as packet sniffing. So packet sniffing is very easy to do, and it's very hard to detect. In addition to seeing information they're not entitled to, malicious actors can also intercept network traffic and alter it. These attacks can cause damage to an organization's network because sometimes you can insert malicious code modifications or alter the message and interrupt network operations. So to give you an example, an attacker can, let's say, intercept a bank transfer and change the account receiving the funds to one the attacker controls. Now, this is a very bad example. I'd say it's usually smaller things like intercepting a lot of transmissions and then trying to infer some sort of information based on the behavior. Because when you're packet sniffing, you're not seeing the actual data that is being transferred, not seeing the plain text, you're using the ciphertext. So the data that's been encrypted. Usually in modern protocols, you also have something equivalent to a hash that is sent alongside the message to prevent message tampering. So it is pretty unrealistic you'd be able to tamper with the message or see any substantive data other than metadata from packet sniffing on its own. Okay, we have backdoor. So I'm sure that you guys have heard about backdoor attacks. Basically, it's just weaknesses that are left by programmers or network administrators to bypass normal access control mechanisms. Now, we add backdoors all the time in practice, but whenever you add backdoors, you have to make sure that you notify your team of it. So that way, if your employment is terminated or if you decide to move on, that somebody can make sure that um, all the backdoors are removed from you. But when you don't disclose these backdoors, so like you give your private server access to a like lab server or something, it could be for convenience, because hashing into lab servers all the time is very tedious with the passwords they provide you. But if you could add a backdoor with your existing access to try and access it quicker, then that access could not be removed from you unless you disclose it to somebody else. So basically, they're intended to help programmers to conduct troubleshooting or like repeated tasks, administrative tasks. But backdoors can be installed by attackers also after they compromise an organization to make sure they have persistent access. So a backdoor with attacks Uh, I remember I was speaking to another cybersecurity practitioner, and in their company, after an attack, the attacker um, was able to receive the credentials of an account and link the multi-factor authentication to like a burner phone. So essentially taking over that unused account and then using that account as a backdoor to access information after the attack has been found out and remedied, because they did not check all of the accounts and their behaviors afterwards. So once the attacker has entered an insecure network through a backdoor, they can cause a lot of damage. They can install malware, as we've seen with the U of A case. They can perform DOS attacks or DDoS attacks too. We'll talk about those in the next slide. Can steal private information, change security settings to make it more vulnerable, and stuff like that. So a DOS attack is an attack that targets a network or server and floods it with network traffic. The objective of a denial of service attack is to disrupt normal business operations by overloading an organization's network. The goal of the attack is to send so much information that a network device crashes or is unable to respond to legitimate users. So you're not trying to steal any data from here. You're not trying to ransom any part of the network. You're just simply trying to make it not work, to make it inconvenient for people to access. So there you go. So in a DOS attack, they are easy to detect and prevent because it's not a distributed denial of service attack. It's just a denial of service attack. It means that one device sends all of the requests. So it's very easy to see when one device sends a lot of requests to your web server. But an example that I've encountered recently was web scraping. So I recently created a web scraper specifically for a research project to bypass some of the interesting ways that Google conducts their queries. So the intent was to have a program that searches Google and then queries the websites and returns the number of keywords that appear on the websites. And then it stores it to a data frame, and you have an Excel sheet of all the URLs that match the keyword and where the keyword is and so on. It makes it easier for me to parse through a lot of data. The issue is that a lot of these, so here's the code, or here's a small subset of the code. So in this particular case, we're sending a request with HTTP basic authorization. And then we also provide something in the headers, such as a user agent, because this is actually a little bit of a bypassing measure, because some websites are way too sensitive to scraping and way too sensitive to queries. So you need to make yourself look more legitimate by providing legitimate headers and stuff like that. And then basically for every URL that Google comes back, we visit the URL and we check it. So this particular piece of code makes it so, let's say if Google returns like 10 links or 100 links from the same website, I'm visiting that website at least 100 times, which does not work when you have the New York Times. So the New York Times likes to check for scraping, and this was completely unintentional. We ended up remedying the situation, but this was completely an accident. But in a strictly definitional sort of approach. This was a denial of service attack that was prevented by the New York Times, even if it was unintentional. All right, so how do we fix this issue? So, as we said before, it is just keeping a lookout. So if we look at the New York Times for reasons that they're seeing it, so clicking much faster, so detecting your clicks, sending kind of injection code with JavaScript to your computer to see if it is responding correctly to that, or having a list of bots with known IP addresses, kind of like a blacklist. So in the very basic case, what you want to do is you want to have a kind of running list of entities that are accessing your website, and then you can tailor it based on uh, you can tailor the size of the list depending on the size of your server and the volume of queries that you're receiving. Um, I believe the standard retention rate is around a week, where it takes every single IP address, how many times they've accessed it, when they've accessed it, sometimes even some kind of sort of metadata to just make sure that everything is going as planned and entities that are sending a lot of requests are dealt with appropriately. Now, this is where DDoS attacks come from. So a DDoS attack is a type of DOS attack that uses multiple devices or servers in different locations to flood this target network with unwanted traffic. So this directly counteracts the list idea, because now you can't see that a specific IP address is sending a high volume of requests. You're seeing many IP addresses, which to you, unless you have already a blacklist of IP addresses, to you it looks like a lot of separate entities, a lot of separate customers are trying to access your server at the same time. So it looks genuine. Um, because each one of them is also sending a normal number of requests. You just have a lot of devices sending a normal amount of requests. So I was actually trying to, for research purposes, trying to find issues with the Bluetooth protocol, because I did not like, whenever you connect devices together, I did not like, let's say, like you're pairing your phone to your car and it asks you for what are the numbers displayed on the screen, and then all you have to do is say okay, because those numbers usually align. So I was actually trying to test a vulnerability with Bluetooth, where I was able to get onto a network, send a hidden Bluetooth request to pair that the phone would pretty much automatically just accept. And then after 30 seconds, it was, um, all the connected devices were made to send requests to my home server and basically conduct a DDoS attack. Um, which ended up being partially successful. On Android devices, it was much more successful than Apple devices, but it wasn't a lot to do. I believe I had network statistics where I was writing network statistics on my home server at the time, and it was showing me the number of requests like exponentially increase, but I don't have it anymore. All right. So we have different types of DOS attacks and DDoS attacks by extension. So we have a synchronized flood attack. So basically in network protocols, you can send different types of packets to signify different actions. So in this type, you simulate a TCP connection and flood the server with SYN packets. So I have a graph here that displays it. So basically we have a client in the TCP protocol. You have to have a handshake where the client sends a SYN, and then a server acknowledges the SYN, and then the client acknowledges the acknowledgement. So in this case, you would have a lot of clients send SYN packets to which the server has to respond with SYN and a knowledge to create a connection. So if you have a lot of actors trying to send SYN packets at the same time, the server cannot acknowledge all connections, and it will basically start flooding and not establishing any more connections, even with legitimate entities. So if the number of SYN requests is larger than the number of available ports on a server, then the server will be overwhelmed and will be unable to function. Okay, so there's a few other types. There's the ICMP. I guess that's just background. So Internet Control Message Protocol. Internet protocol used by a device to tell each other about data and transmission errors across the network. So ICMP requests are like status updates from a device. A device will return error messages if there's a network concern. And basically you use ICMP to just check in on a device in a network to make sure that it is configured and working well. So in ICMP flat attack, what you do is you send, instead of sending the SYN packets as you were sending in the last one, you would be sending a lot of ICMP packets to essentially do the same thing, overwhelm the server with ICMP requests where the server responds with the status of the server. So ICMP is also a DOS attack, sends ICMP packets to a network server, which forces the server to send an ICMP packet, which uses up all the bandwidth for ingoing and outgoing traffic and causes the server to crash. Okay, so what we have is the ping of death. Now, the ping of death is a very outdated method of DOS attack. It does not work anymore, unfortunately, unless you're on an outdated machine. But basically, a type of DOS attack that's caused when a hacker pings a system by sending it an oversized ICMP packet, because ICMP packets are meant to be smaller or equal to 64 kilobytes. So on older devices, back in the day, if you were sending over 64 kilobytes, it would not know how to respond to the request, and it would cause the system to crash pretty much. But as I said before, it does not work on most networks anymore. Okay, so we have a small case study, and then we have like a small assignment, I guess, or just a way to apply all these concepts that we've learned today. So we have a case study about creating a botnet, targeting a DNS server, and making code open source prior to the attack. So we have a few terms here. So a botnet is a collection of computers infected by malware that are under the control of a single threat actor. Each computer in the net can be remotely controlled to send a data packet or a request to a target system. In botnet attacks, cyber criminals instruct all the bots to send packets to the same receiver or to the same server at the same time, which is a DDoS attack. So basically what we've seen earlier in the presentation, where I was able to manipulate the Bluetooth protocol to have a lot of devices send packets to my home server. All of those devices are bots in a botnet. Okay, so in this particular case study, a few very smart decisions were made, especially smart decisions for at the time. So the first thing that happened is that, here, I'll do this. The first thing that happened is it was 3 DDoS attacks and not a single one. Usually there are measures even for DDoS attacks to see them, but if you're conducting multiple DDoS attacks at that point in time, there was just no way to counter them all at the same time. Also, usually whenever you do DDoS attacks, it's usually an activist organization sending packets to servers of a particular company, of a particular subset of companies. So think climate activists that were disenfranchised by oil companies sending a lot of requests to those oil companies' servers to make them crash. In this case, the target was DNS providers, or specifically DIN. So basically, it was untargeted in a sense that whenever we type in, let's say, Google or any other website, the request goes to a domain name system provider or a DNS server. So our request goes to a server, which then takes that request and turns it into IPs for us to for us to for us to actually visit a website. So that way we don't have to remember the IPs. We just have to search stuff up. So if you make an attack on the DNS servers, it means that anybody else that is trying to use the internet will not be able to, because they'll be typing in the words into a search bar, and it will not work because that DNS server cannot translate it to what the network needs to forward your request to the appropriate server. So a few smart things that happened here is there were multiple attacks at the same time. So even after the first cybersecurity incident, there was a second and a third, which makes it very difficult for centers of operation or security operating centers to um, respond to. In addition, it was targeted against a DNS provider, which makes it very it's untargeted, but it is very harmful because it is untargeted, because you're targeting so many people. And in a third thing that was really smart about this attack is that usually in digital forensics, what you do is you create a signature out of the requests or out of some pieces of the code that were used to run the attack, and then you try to track that signature to whoever created the attack or whoever first posted the attack. In this case, the code to the attack, and therefore the signature of the attack, was published on, I believe, 4chan and other message boards a day prior to the attack, meaning that you just cannot track down who did this attack unless you start checking down the bots on them on their own. So it was really smart for them to post the code to the attack, because then it can't be traced back to a single author. Okay, so this was a scenario for when we were together, but basically just what a DDoS attack looks like from the blue team side. So let's do the quick primer, and then maybe I'll read off the document for a while, and then all the documents will be posted for you along with the solutions if you want to follow along. So we have a network protocol analyzer, which is a packet sniffer, so things like Wireshark, which is a tool designated to capture and analyze data and traffic within a network. They're commonly used as investigative tools to monitor networks and identify suspicious activity. Then we have TCP dump, is a command line network protocol analyzer that analyzes a brief packet analysis, that provides a brief packet analysis and converts key information about network traffic into formats easily read by humans. So in the next slide, there's a little bit of a example of an output from TCP dump. So if you have TCP dump installed, usually it's on Linux systems, but you can install it on any system. Just by putting TCP dump, it will do a live TCP dump of everything that's going on the network that you're connected to. So the beginning will be a timestamp with hours, minutes, seconds, and fractions of a second. Then you have the source IP and the source port, and destination IP and destination port. So basically where the request came from and where is the request going to. And once again, TCP dump works on the network that you're connected to. So you would be seeing a lot of source IPs and a lot of destination IPs of everybody who's connected to the network, unless the network is specifically protected against packet sniffing. So scenario. So I'm going to be looking at scenario documents. Let me see if I can change the sharing to a different tab here. Okay, there you go. So we have this document here. Okay, so you will analyze DNS and ICMP traffic in transit using data from a network protocol analyzer. You'll identify which network protocol was used. In the internet layer of the TCP/IP model, the IP formats data packets into IP datagrams. The information provided in the datagram of an IP packet can provide security analysts with insight into suspicious data packets in transit. So hold on, let me see if I can pull up a chart of what packets are called in every layer. Okay. So when it says datagram of an IP packet, this is a, let me present something else. Okay. So this refers to this layer. So as we were looking at the TCP/IP model and the OSI model, basically the traffic in transit has different names. So whenever it's in the network stage, it's called the data frame. And the internet and the network stages, it is called the datagram. So this is where you'd have your IP addresses, which is why they called it a datagram. And then in transport, it'll be a segment. Then the application, it would be a segment as well. Just wanted to say why it was called a datagram there. So if we go back, knowing how to identify potentially malicious traffic on a network can help cybersecurity analysts assess security risks on a network and reinforce network security. So you are a cybersecurity analyst working at a company, specializes IT services. So several customers of clients reported that they are not able to access the client company. So they cannot access this website and saw a destination port unreachable after waiting for the page to load. You're tasked with analyzing the situation, determining which network protocol affected during the incident. To start, you attempt to visit the website and also see destination port unreachable. Troubleshoot the issue, you load your network analyzer tool, TCP dump, and attempt to load the web page again. To load the web page, your browser send a query to a DNS server. So we've talked about DNS servers just a bit ago via the UDP protocol. This is whatever to retrieve the IP address for the domain name. This is part of the DNS protocol. Your browser then uses this IP address. So you send requests to the DNS server, finds the IP address, and then you send the IP address as a destination IP, and then send your request to that IP. So DNS is like a translator. So then you send an HTTPS request to the web server. The analyzer shows that when you send UDP packets to the DNS server, you receive ICMP packets containing the error message UDP port 53 unreachable. So this is an important part of your investigation that you'll be doing. So the analyzer shows that when you send UDP packets to the DNS server, you receive ICMP packets containing the error message UDP port 53 unreachable. So you can see the TCP dump. And then you also have all these observations that you can take a look at. But as we've talked about, DNS servers are basically translators. And we've talked about what an ICMP packet was, which was a way for network devices to communicate their status. So you talk to the translator, and the translator says that this UDP port is unreachable. So now it's on to you to look into all this TCP dump and all these observations to see exactly what went wrong, and just a little bit more of a backup. And then after analyzing the data presented, identify trends in the data, assess which protocol is producing the error message for the DNS server for your website. So basically, if you wanted to, you could also write up a brief summary of the log analysis, provide a few details, and interpret the issues found in the log. This was your standard, not everyday occurrence, but like a monthly occurrence or bi-monthly occurrence report. pretty much. So here you go. Again, all these documents will be posted. I'm going to go back to the presentation and we can finish up for the day. Okay, so that is also in the document. And then, so this is a little hint, but it said that UDP 53 was the port that was unreachable, and you see that that port is used for DNS. So again, that port is used to communicate to the translator. And then if you wanted to look into all the ports and what they're usually used for, you can look at that link there. And then that's it. So this was CHADS network security. A cohort. We talked about first we talked about malware. We talked about the importance of cybersecurity. We talked about the different type of packets like SYN packets and ICMP packets. We talked about protocols such as UDP and TCP. We talked about TCP dump and how it's used. We talked about packet sniffing, DOS, and DDoS attacks. So if you guys have any questions, feel free to message me on Discord. But other than that, I hope you have a great day.